if we take a look at this problem, let's first look for the perimeter. So in looking at the perimeter, well, we know, well, actually, the easiest thing to find is angle C. What's angle C going to equal? 90 degrees, right? So we know that angle C is 90 degrees. Because this is a parallel, or because these lines are parallel, you're going to have same side interior angles that are supplementary. Supplement of 90 is 90. Okay, so we know that relationship. Right, we also can see now, in order to build this, we need to imagine breaking this down into figures that we're more familiar with. Okay, so we have this rectangle here, okay, and so opposite sides in a rectangle are equal. So this side is 8, this side is 6. And so in order for us to find this missing side, we have this right triangle with one leg of 6 and a hypotenuse of 10. If you imagine this is 2 times 3, 2 times 5, we have a common triple, a 3, 4, 5. So the multiplier of 2 gives us an overall side of 8. So now we can add our sides together. So 3/8 is 24, plus 6 is 30, plus another 10 gives us 40. So we have our perimeter of 40. Okay, so it looked like most of you got that. Okay. All right, now the difficult part tends to come here. If you're not directed specifically what to do, is how do you find angle A and D, or in this case, if you're not given any other angles but this 90 degrees? Okay, and what did some of you wind up using? You have a right triangle, so that should trigger a couple things. For sides, it should trigger Pythagorean theorem, right? And possibly trig ratios. For angles, it should always trigger trig ratios. If you use law of sines, that it works, but it's not the most efficient way. Okay, so let's take a look at trig ratios. Even if you choose, in this case, angle A, we want to find what this angle is. It doesn't matter, since we have all three sides, 6, 8, and 10, you can choose any of the trig ratios you want. Let's say we choose 6 and 10. So we have the opposite and the hypotenuse of that. So which trig ratio is that? Sine. So we could set up the sine of A is equal to the ratio 6 over 10, which means the angle itself can be found by taking the inverse sine of that ratio. And so if we calculate that, here, our inverse sine of the ratio 6 over 10, put it in decimals, and then hit enter, we get our answer to be 36.9. Okay, so there's our angle A. Now, what I want to show you is, what if instead of using 6 and 10, what if you wanted to use 8 and 10? Okay, so if you used adjacent and hypotenuse, which trig ratio would that be? Cosine. So you could have said that the cosine of A is equal to 8 over 10, which means A is going to equal the inverse cosine of that ratio. And if we took that calculation, the inverse cosine of 8 over 10, put it in decimals, we get the same exact answer. It's still going to be 36.9. Okay, we could have also done opposite and adjacent. We have 6 and 8 for those measures. So opposite and adjacent is which trig ratio? Tangent. So we could have said that the tangent of A is equal to 6 over 8, which means A itself can be calculated taking the inverse tan of that ratio. And if we do that, the inverse tangent of 6 over 8 and calculate, we still get the same thing. Okay, so no matter which one you chose to use, you'll come up with the exact same angle measure for A. Okay, then to find the whole angle D, so in order to find this whole angle D, we first need to find the portion of angle, this portion of angle D that falls into this right triangle that we created. And how would we find that? The acute angles of a right triangle are always complementary to one another. They add up to 90. So if we just take 90 and subtract the measure that we just found, 36.9, and hit enter, we get our angle for this portion, 53.1. And then we're going to add another 90 to that to get this whole angle measure here. So if we add 90 to 53.1, we get 143.1. So angle A is going to be 36.9. Angle D is going to be 143.1.